For this problem, we're going to be working on a type of problem that is called a maximization problem. So this says, a farmer has 2,000 feet of fence with which to fence a rectangular plot of land. The plot lies along a river so that only 3 sides need to be fenced. Estimate the largest area that can be fenced. Okay, so we're trying to find, so he has 2,000 feet of fencing, and we want to use all 2,000 feet of that fencing to create a fence, a rectangular fence along this river. And we want to know what is the biggest area that we can create with 2,000 feet of fencing. So I always like to add in a visual here. So it does say that this is up against a river, so that's going to be my river. So then our rectangular fencing is going to look something like this. We technically are just going to be using 3 sides of fencing since the border of the river is going to be our other side here. Now, it says that we have 2,000 feet of fencing. It doesn't say how much we're going to put for the length, how much we're going to put for the width. That is what we need to figure out. Now, this is how we hash this out. Now, if we don't know what something is in math, typically we're going to designate that as X. So what I'm going to do is I have no idea how many feet of fencing we're going to use for the width, so I'm going to call it X. And what we know about rectangles is opposite sides are equal. So if that left side there is X amount of fencing, so is the right side over here. They're both X feet of fencing. Now, if I have 2,000 feet of fencing and I put X amount over here and X amount over there, technically what I'm left with is I have 2,000 feet of fencing minus this X over here on the left and minus the X over here on the right. So what that's actually going to look like is I have 2,000 feet of fencing minus the 2X that we're going to use for the 2 sides. Whatever's left over after that is what we have to use on this length right here. So this is the setup for this problem. Our widths, we're typically going to always say X. Our length is going to be however much fencing we have in the beginning minus 2X, almost always, as long as this is the shape we're working with. Now, it wants us to estimate the largest area that can be fenced. So what we actually need to know is we do need to know the formula for area of a rectangle. And area for a rectangle is length times width. So let's plug in what we know here. We said that our length is going to be 2,000 minus 2X, and then times our width, which is an X. Multiply this out. X times 2,000 gives us 2,000X minus X times the negative 2X gives us a minus 2X squared. Do notice that this is a quadratic equation, right? That negative 2X squared makes this a quadratic equation. And if we want to find the largest area, we want to maximize this. And when it comes to maximizing with quadratic equations, we do have a little mini formula that allows us to find the max and minimum values for that equation. That looks like this. Negative b over 2a, and then f of negative b over 2a. So we want to use this, specifically the negative b over 2a. What this is going to do is this is going to solve for x for us. Now, keep in mind that negative b over 2a comes from just your standard form of a quadratic equation, ax squared plus bx plus c. So a is the coefficient of x squared, b is the coefficient of x. So for our problem, a is actually a negative 2, and b is the 2,000. So if we plug that into our problem here, that's a negative, which is part of the formula. B is 2,000 over 2 times A, which we have a negative 2. And when we multiply this out or we simplify this, that's just a negative 2,000 up top over a negative 4. And when we reduce this, we get 500. So what this means is that x is equal to 500. Now it wants us to find the area, length times width. And remember, the width we did designate as x, right? So we know that we're going to do 500 for our width times whatever the length is. Well, the length we designated as 2,000 minus 2x. So if we plug in the 500 for x that we just found out, that gives us 2,000 minus 1,000, which just leaves us with 1,000. That means our length was 1,000. Our width was 500. We found that out when we did the negative b over 2a. So when we multiply that out together, length times width gives us 500,000 feet squared. That is how big of an area we would be able to fence in along this riverbank.